Abnormal behavior of nitrogen. Abnormal behavior of nitrogen. Nitrogen shows anomalous or abnormal behavior with the other elements of the group 15 due to following causes. First is high electronegativity value. High electronegativity. High electronegativity value. High electronegativity value. Second,
pressure, mechanical,
small atomic size.
It is used in industry.
Small atomic
Mechanical pressure.
atomic size. Small atomic size. Third point, non-availability of vacant d orbital.
Diagram.
Non-availability of vacant d orbital.
Electrocardiography.
Tendency to form multiple bonds.
Cardiography.
Tendency to form multiple bonds. Tendency to form multiple bonds. Okay. Abnormal behavior of nitrogen. High electronegativity value. Second, small atomic size. Third, non-availability of vacant d orbital. And fourth, tendency to form multiple bonds. Okay. Next, differences between nitrogen and other members of the group 15.
Yes. It is used in industries for the study of mechanical
differences,
indicator diagram of internal
differences between nitrogen and other members of the group 15. Okay. Differences between the nitrogen and other members of the group 15. Okay. First member of the group differs in properties from the rest. Okay. First member of the group differs in properties from the rest due to small size and lack of d orbital in its outermost configuration, and such properties different from phosphorus. Nitrogen differs from the other elements in following respect. First, in standard state, nitrogen exists as nitrogen gas, but phosphorus as P4 solid. But phosphorus as P4 solid, arsenic and antimony as arsenic and antimony as AS4 and SB4 also exist in solid state. Phosphorus Due to large size of phosphorus, pi bond is not possible. Due to large size of phosphorus, pi bond is not possible due to PP overlap and show P2 does not exist. P2 does not exist. Okay. Second point. Second point. Second point. Second point. Nitrogen does not show allotropy. Nitrogen does not show allotropy. Nitrogen does not show. Nitrogen does not show allotropy. Allotropy. Phosphorus, arsenic, antimony show allotropy. Okay. Third point. Nitrogen form N2O, NO2, N2O3, N2O5, but phosphorus form P4O6 and P4O10, P4O6 and P4O10. Okay. Fourth point. In case of nitrogen hydride, NH3, in case of nitrogen hydride NH3, there is hydrogen bonding. There is hydrogen bonding. Hence, its boiling point is comparatively higher. Hence, its boiling point is comparatively higher. Okay. Higher. In case of other hydrides of the elements of the group, there is no hydrogen bondings. Okay. In case of other hydrides of other elements of the group there is no hydrogen bonding. There is no hydrogen bonding. Okay. Fifth point. Nitrogen is non-metal while other are metallide and metals. Nitrogen is a non-metal while others are metallide. And metals. Okay. 6 point. Nitrogen does not contain vacant d orbitals. Nitrogen is a non-metal while other are metallide and metals. Nitrogen does not contain vacant d orbitals. Nitrogen does not contain vacant d orbital. Contain vacant d orbital. Hence it does accept. Hence it does accept lone pair. Thus NCl3 on hydrolysis gives ammonia NH3 and hydrochlorous acid and hypochlorous acid and hypochlorous acid, okay, hypochlorous acid, NCl3 plus 3H2O, that is NH3 plus HOCl, okay. Nitrogen does not contain vacant d orbital. Nitrogen does not contain vacant d orbitals, hence it does accept a lone pair. Thus NCl3 on hydrolysis gives ammonia and hypochlorous acid, okay. Nitrogen does not contain vacant d orbitals, hence it does accept lone pair. Thus NCl3 on hydrolysis gives ammonia and hypochlorous acid. NCl3 plus 3H2O, that is NH3 plus HOCl, okay. Reverse is the case with other highlights of this group. Other elements of the group are the electron acceptors. Due to presence of vacant d orbitals in them, on hydrolysis PCl3 and AsCl3 gives acyl hydrochloric acid and oxy acids. PCl3 plus 3H2O, that is H3PO3 plus 3HCl, okay. 7 point. Nitrogen forms more number of oxides in comparison to other elements. Nitrogen forms more number. 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 Okay. Nitrogen forms more number of oxides. More number of oxides in comparison to other elements. In comparison to other elements. In comparison to other elements. Okay. 8 point. Point 8. Nitrogen forms multiple bond like. Nitrogen forms multiple. Nitrogen forms multiple bonds like nitrogen triple bond nitrogen triple bond oxygen due to pp overlap. Due to pp overlap, others do not. Nitrogen forms multiple bonds like nitrogen triple bond nitrogen triple bond oxygen due to pp overlap, others do not. Okay. IX, that means 9 point. Nitrogen forms oxide with oxidation state from +1 to +5. Okay, whereas other elements form oxides in oxidation states +3 and +5 like M2O3 and M2O5. Okay, 10 point. Point 10. The maximum covalency of nitrogen is 4. The maximum covalency of nitrogen is 4. As in NH4. Positive. But maximum covalency of other maximum covalency of others maximum covalency of others is 6 as in PF6 minus. Okay. Next point, point 11. Next point 11. Point 11. Okay. 1 minute. Next point, point 11. 1 minute. Point 11. 11 point. Point 11. Okay. Next point. Point 11. Okay. Nitrogen forms only NX3 type halides. Nitrogen forms only NX3 type halides. NX3 type halides, while other forms pentahalides. Other forms pentahalides like PX5, ASX5 and SBX5 forms trihalides. BI forms trihalide BIX3 due to inert pair effect. Due to inert pair effect, hence phosphorus forms PCl3 and PCl5 both, but nitrogen only forms NCl3. Okay. 12 point. Point 12. Nitrogen shows oxidation state form. Nitrogen shows oxidation state from -3 to +5, while others show +3 to +5. Okay. Point 13 point. Nitrogen forms show many stable compounds while others do not. Nitrogen forms show many stable compounds. Many stable compounds while other forms complexes. While other form complexes. Sorry. Nitrogen forms show many stable compounds while others do not. Okay. 14 point. Point 14. Okay. Nitrogen does not form complexes compound while other forms complexes compounds. Nitrogen do not form complexes compounds while other form complexes compound. Okay. Other forms complexes compounds due to presence of vacant d orbital in them. Due to presence of d orbital. Due to presence of d orbitals. Okay, possess of vacant d orbitals. Sorry, d orbital, no d orbitals only. Vacant d orbitals. Vacant d orbitals in them. In them. Okay, in them. Okay, and the next point, 15 point. Point 15. Except NCl3. Except NCl3, the halides of nitrogen are unstable. The halides of nitrogen, are unstable, and highly explosive, and highly highly explosive, while halides, while halides, while halides, while halides of other elements of this group, while halides of other elements of this group, are stable, okay, explosive, while halides of other elements of this group are stable. Next, diagonal relationship of nitrogen and sulfur. Okay, diagonal relationship of nitrogen and sulfur. Diagonal relationship, diagonal relationship of nitrogen with sulfur, diagonal relationship of nitrogen with sulfur. Okay, the element of second period of periodic table show many similarities with the elements of third period. This relation is known as diagonal relationship. This is due to same value of ionic potential and electronegativity. Okay, you can show as example first. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Okay, lithium is diagonally related to magnesium, beryllium is diagonally related to aluminum, boron is diagonally related to silicon, carbon is diagonally relative to phosphorus, and nitrogen is diagonally related to sulfur, and oxygen is diagonally related to aluminum, chlorine diagonally related to chlorine. Okay, and then nitrogen is diagonally related to sulfur. Okay, diagonally related to sulfur. Nitrogen is diagonally related to sulfur. Okay, nitrogen shows diagonal relationship with sulfur, which is the member of group 16. These are the main similarities between both elements. First, nitrogen and sulfur both are non-metals. Nitrogen and sulfur both are non-metals. Both are non-metals. Both are non-metals. Okay. First point. Second point. Both the elements are highly electronegativity. Both the elements Both the elements are highly electronegative. Both the elements are highly electronegative. Highly electronegative. Highly electronegative. Okay. Third point. The oxides of both elements are acidic. Oxides of both elements. Oxides of both the elements are acidic. Fourth point. Both form strong oxy acids. Wait a minute. Fourth, both form strong oxy acids. Both form strong oxy acids and their salts. Okay. Fifth point. By combination with hydrogen. By combination with hydrogen. Both form covalent hydrides. Both form covalent hydrides. Both forms covalent hydrides. Okay. Next, elements of group 16 oxygen family. Okay.